Welcome back. This is Dr. Biju Vasudevan. In this video, we are going to discuss chapter 8.1, which is falling in week 13. The remaining chapters, remaining sections of the chapter 8 will be for week 14 and for week 15 as well. So, in this week, we need to complete only one more topic: basic counting principles and permutations. Let's start with definition. Basic counting principle. Suppose that a procedure involves a sequence of k stages. There are k stages, and let n1 be the number of ways the first stage occurs. So in the first stage, you have n1 ways to get one event occurred. Second stage, there are n2 ways. There are the sequence as actually you can say that there are k stages for every stage: n1, n2, n3, and finally for kth stage there are nk ways to get the event occurred. Then the total number of ways will be the product of all these numbers. Let's see the total number of different ways a sequence can occur is the product of this one. The example is given. So this is first basic counting principle. What is all this about? Let's take an example. Suppose the two roads connect cities Amman A, Madaba B. Roads connect two cities and 4 connect Madaba and Rumaila. 5 connect 5 first only 2 roads connect to first 2 cities. 4 roads connect another 2 cities, and 5 roads connect Rumayala and Al Hassa. Let them be 4 different cities, isn't it? 4 different. See. So to drive from Amman to, so you can draw this one. What is it? Amman B, Madaba C, Rumayala. This is Madaba. This is Rumayala. This is Amman. And finally, Al Hassa. Al Hassa is D, isn't it? D, Al Hassa. Just draw them. The first see, go back and read now this one. The first n1 with the number of ways that the first event occurs. You can call it event, isn't even occurs. So first event is connecting A and B. There are two ways. To connect B and C, B is Madaba and Rumayala. There are 4 roads, 1, 2, 3 and 4 roads, 4 ways. Second event can occur in 4 different ways. Second event is reaching B to C. Third event, from C to D, Rumayala to Al Hassa. There are 5 different ways. So the question, what is the question now? To drive from Amman to here, you are starting and ending at here. If you want to start at Amman and end at Al Hassa, D is the last station, ending point, starting point. Totally, how many routes are possible? So now this is the product of all these 3. 2 into 4, 8 into 5, which is 14. This is what the meaning of this one. The first event has 2 ways to occur. Second event has 4 ways to occur. There are only 3 events. Connecting the cities. So multiply them, you will get the number of ways. That is it. The answer is on the PowerPoint. You can check. Another example is also given: license plates. A certain vehicle license plates in Saudi Arabia consists of 3 digits followed by 3 Arabic letters. If repetition is allowed, how many different license plates of this type are possible? So, of the Arabic numbers, you should write from 0. This dot is 0, isn't it? 1, 2, 3, something like this, 3, and the last is 9. There are 10 numbers, and I don't know letters. You can write how many letters are there. Arabic letters are they 28? So now what's going on? The number plate will have 6 spaces, isn't it? The first space, first 3 for numbers, the last 3 for letters, isn't it? First 3, and there are 10 numbers. First number can be any of the 10 numbers. If repetition is allowed, first case. If repetition is not allowed, the second case, isn't it? Repetition first number can be any of the 10 numbers. Remaining will be 9, but you can use the same number which has been given to the first question. So again, 10 out of 10 numbers, any one number can come here. Again, out of 10 numbers, any one number can come third position. Here repetition is allowed. If repetition is not allowed, it will be 10 letters numbers for the first position. The remaining, if you allocate one number here, the second remaining 9 numbers will go to second place. If you allocate another number to second place, remaining 8 numbers will go to third place. This is when no repetition is allowed. But our case, repetition is allowed. So all the 3 places can be filled by any of the 10 numbers. The same can be the out of 28 letters, any letter can occupy the first position. Any out of 28, any other letter can occupy this position. So we have to multiply all these. The product of all these will be the number of different license plates possible. If you multiply this one, it will be coming around. This is 9, 5, 2, 21. What is this? 21. That's it. Okay, so there will be exactly 21 952 000. This is 21,952,000 ways number plates possible. So that's it. If no repetition is allowed, you can change and try this one. The next is, we are moving slowly to the concept of permutation. What is this? In this case, we have been given an ordered arrangement of n objects selected from an ordered arrangement of r objects selected from n objects. Arrangement, the line is to be underlined, that is the word to be underlined is arrangement of r objects out of n objects. The formula has been given here. So the formula gives you an idea. NPR will be n factorial divided by, we can simplify this one, n factorial divided by n minus r factorial. You should know what is factorial. What is 3 factorial? So this will be here NPR, permutation of r objects out of n objects. The formula is n factorial over n minus r factorial. What is factorial? When you write 5 factorial, it means 5, 3, 5, 4, 3, 2, 1. 1 to 5, multiply all the natural numbers. If it is 6 factorial, 1 to 6, isn't it? In this way you should go ahead. So n minus r. So if it is 5p2, how do you find 5p2? 5 factorial, isn't it? 5 factorial is 5 factorial divided by 5 minus 2, 3 factorial. This 5 factorial is 5 into 4 into 3 into 2 into 1 divided by 3 into 2 into 1. So first 3 will be cancelled, it will be 5 into 4. What do you mean by this one? Without repetition, actually this one. If there are 5 objects but 2 places to be filled, A and B, there are 1, 2, 3, 4, 5 numbers. You have to fill you have to arrange these numbers in the order A, B here, right? So how many possible ways? Roughly try this one. The answer by using this one is 5p2, which is 5 into 4 is 20. What is happening? Out of these 5 numbers, any one can be assigned. So there are 5 possible ways to assign one number to the first position, either 1 or 2 or 3 or 4 or 5. If no repetition is allowed, no repetition, you don't have right to choose the same number again, isn't it? So if any one of the number has been assigned to A, remaining there are 4 numbers. So the next place will be filled by the 4 remaining numbers, any one of the 4 remaining. So the first position has 5 ways to get filled. The second position has 4 ways to get it filled, isn't it? So 5 into 4 is 20. This is the way. So if I have 3 places A, B, C, you can say 5, 4, 3. It is reducing in. So that is what given by this formula, NPR. NPR is n factorial. You don't need to use this formula directly. You can use, if I ask 10p3, you can write 10 into 9 into 8, 3 terms down, isn't it? If I ask 12p4, you can write 12 into 11 into 10 into 9, 4 numbers downwards, isn't it? So 12, you start from 12 and 4 is the number R, so 12p4. That's the way you have to calculate this one. This is called permutation. This is called a permutation, which is arrangement of R objects out of n objects. Clear? Okay. Let's take an example here. Lawyers Azhar, Hamza, Nasim and Amir want to form a legal firm and will name it by using all 4 of their last names. So each one have a last name, L1, L2, L3 and L4, last name 4. How many possible names are there? We cannot repeat one name twice, isn't it? Therefore, there are 4 possible words, as there are 4 possible last names, isn't it? They have to give a name for this firm, legal firm. First position, you can give 1, 2, A, B, C, D. First word can be filled by any of the 4 names. If you use one name here, there are remaining 4 names. So remaining 3 names. So the second position can be filled by remaining 3 names. If you use another word here, there will be only 2 word names. Last names, isn't it? So out of the 2, 1 can be used here, so 2 here. And finally only 1 remaining. So this is nothing but 4 factorial. So when we understand that this is NPN, when R is equal to N, you have 4 words. Out of 4, all the 4 should be arranged in order. So it is 4 factorial. NPN is N factorial. NPR is N factorial divided by N minus R factorial. But NPN, when R is equal to N, is N factorial. This will be 0 factorial when R and N are equal. 0 factorial is not 0 factorial is actually 1. So 4 factorial, the answer is multiply all these 4, which is 24. That is it. Next, now we are entering to the definition of permutation. An ordered selection of R objects without repetition. No repetition in the case of permutation, right? Taken from n objects. It's called permutation. Actually, it's arrangement. You need to arrange it in order. So there will be a highlighting word arrangement in the case of permutation. So the formula we have seen NPR, that is NPN is n factorial, and this have been seen. Now let's go to the exercise problems. Chapter 8.1, exercise problem number 1. Now let's use the number counting principle 1 and permutation to solve this. In a production process, a product goes through one of the assembly lines. So assembly lines A, assembly line B, isn't it? No. Let's read the question carefully. The product goes through one of the assembly lines A, B or C and then goes through one of the finishing lines D, E. Okay, we have to draw the tree. We have to draw a tree that indicates the possible production routes for a unit of the production. How many production routes are possible, right? You have a starting point. You have to apply that is A, B, C. Every product has to undergo A, B, C. The product is here, isn't it? And from A you have to then the product goes through the finishing lines D, E. Through after if you go to A, then again go to D or E. If you go to B, again D or E. If you go to C, again D or E. Is that all? That's all. So how many routes are there? 1, 2, 3, 4, 5, 6, 7. So 6 possible production routes. That's the question. How many production routes are possible? You are starting from here. Every product has to choose one of the assembly lines, either A, B, C. So if you go this way, you will end up here or here. So there are 6 ways to complete the production. This is so how you get. In the first case, there are 3 ways to occur. The 3 ways, out of the 3 ways, one has to be chosen by the product. Again, if you choose A, B, S, again there are 2 ways. So the product of 3 into 2 will be 6. So totally there are 6 ways. This is counting principle. Now in the similar way, you try this problem. A red die is rolled. And a green die is a red die is rolled and then a green die is rolled. Draw a tree diagram to indicate the possible results. How many results are possible? That's the question. What is a die? When you roll a die, there are 6 possible outcomes. Either 1, 2, 3, 4, 5, 6. It can be a cube. Actually, it's kind of cube with 6 different spaces, isn't it? So every side will be numbered. So there will be 6. So outcome has 6 possible numbers. When you throw a die, there are 6 possible outcomes. 4, 5, 6. 1, 2, 3, 4, 5, 6. This is a red. You are throwing a red die is rolled. There are 6 possible outcomes. Again, a green die. After, if it is showing 1, then still there are 6 more possible cases. For every number there are again 6 more possible cases because another die is thrown. So there are other 6 ways for green die, isn't it? So totally 6 into 6, there are 36 results possible. In this way you can complete the diagram for every term. Again 6 lines possible, 6, isn't it? So that's it. A coin is tossed 4 times. A coin is tossed 4 times. Draw a tree diagram to indicate the coin starting point. You are tossing the coin first time, there may be head or tail. You are tossing the coin second time, again head or tail. So first time there will be 2 outputs, again second time there will be 2 outputs, isn't it? Head or tail. Third time, again for everything there will be head or tail, head or tail, head or tail, head or tail. Again there is a possibility. Every outcome is multiplied again by 2, isn't it? Every stage you have 2 more chances to get. So again fourth time you are tossing a coin, again 2 outputs from everything. So this is again 2. What is it? 2 to the power 4 is it 16 possible ways. can complete this one. Head or tail from every branch. That's it. This problem, very simple one, you can try. A student must take a mathematics course, a philosophy course, a mathematics course, a philosophy course, and a physics course. There are 3 courses. The available mathematics classes are category. There are how many mathematics classes? Category theory, measure theory, real analysis, combinatorics. So there are 4 mathematics classes, philosophy classes, logical positivism, epistemology, and model logic. There are 3 philosophy classes, and physics are classical mechanics, electricity and magnetism, quantum mechanics, general relativity, cosmology. There are 5. 1, 2, 3, 4, 5. 5 physics courses. So how many ways are there? By basic counting principle, how many 3 course sections can the student make? So multiply them. What do you get? 4 into 3 into 5, 15 into 4 is 60 possible ways for the student to choose all the 3 courses. And how many ways is it possible to answer a 6 question multiple choice examination? If each question has 4 choices, you know this one. First question again 4 choices, second question 4, third question 4 choices, fourth question 4, fifth question 4, sixth question 4. Multiply them. This is 4 to the power 6. Use calculator, you will get to 4096, because only one choice is selected. So how many ways are there to answer the question paper? You can draw the tree if you want to check. First answer will be any of the 4 from everything. Again a 4 will come from every branch. Again 4 from every, again 4 branches. It will go like this. Okay. In how many ways is it possible to answer a 10 question true false? You try the similar way. You try this one. It's very simple. In the following problem, determine the values. What is it? 6p3. We know how to follow. Under 6 into 5 into 3. 3 units, 3 numbers backwards from 6. So 6, 5, 4. 6, 5, 4. 6, 5 into 30. 30 into 4. 120. Answer. 120 is the answer. Next. Flynn, Peters and Waters are forming an advertising firm and agree to name it by their last names. 3 last names. So they have 3 last names. Last name 1, last name 2, last name 3. So there are 3 words for the firm. First portion can be filled by any of the 3 names. If you use one name here, there are remaining 2 names. Out of 2, 1 can be chosen here, remaining 2. This is 3 factorial, which is 3p3, isn't it? The answer for 3 factorial is 6. How many ways can a judge award first, second and third prizes in a contest having 8 contestants? Okay. The first portion can be given to first, second and third, isn't it? Third portions. First portion can go to any one of the 8 members. So 1 out of 8. If first portion goes to one person, there will be remaining 7 persons. So out of 7, 1 should be. So 7 ways are there to get second place. If 2 members are chosen for first 2 places, there are remaining 6 members. So it is 8 into 7 to 6. Use calculator, you will get 336 is the answer, which is actually 8 members, 3 places. 8p3, permutation of 3 members out of 8. And the last problem of this chapter today that we are going to discuss is, how many 6 letter words from the letters in the word made are possible if no letter is repeated. So there are only 6 letters here. All the letters are different, isn't it? All the letters are different. So 6 different letters we have to choose out of 6 letters. So all letters has to be chosen out of n letters. 6 factorial. Use calculator. 6 factorial. 6 into 5 into 4 into 3 into 2 into 1, which is 720. That's the end of this video. Thank you very much.